Nuclear fusion. The energy of the Sun comes from a process called nuclear fusion. This is joining or fusing smaller nuclei to form larger ones. There are two processes you need to know about. The first is the hydrogen cycle. Here we have 4 protons, or hydrogen nuclei. What can happen is 2 protons can join together, with one immediately undergoing beta plus decay to become a neutron. So we get a heavy hydrogen, or deuterium, which is a proton and a neutron joined together. We also get the positron, or beta plus particle, and an electron neutrino. So let's see that process taking place. I'll have these 2 protons fusing and these 2 protons fusing. It's probably best to just concentrate on the top pair. So the 2 protons come together. One immediately undergoes beta decay, becoming a neutron, and they've ejected a positron and a neutrino. What can then happen is another proton comes along, forming helium. This then releases a gamma ray. Again, if we look just at the top one. So here's the proton, which comes along, joining up here to form helium-3, and the gamma ray is emitted. The positron will quickly meet an electron, leading to annihilation. This will release more energy in the form of gamma rays. Let's look now at what happens to the 2 helium-3s we've produced. If they fuse together, they'll form a helium-4 and release 2 protons, like this. So the 2 helium-3s come together, 2 protons come out, and we're left with a helium-4 and 2 protons, which can go on to be involved in further fusions. The carbon cycle is another way of fusing protons, or hydrogen nuclei, to become helium. This also takes place in the Sun. Let's start with a carbon-12 absorbing a proton to become nitrogen-13. This is unstable and undergoes beta plus decay to become nitrogen-13. The nitrogen-13 can absorb a proton, becoming nitrogen-14. This then absorbs another proton, becoming oxygen-15. The oxygen-15 undergoes beta plus decay to become nitrogen-15. The nitrogen-15 absorbs a proton, again becoming carbon-12, and a helium-4 nucleus. And that brings us back to the beginning. So what we've done here is brought 1, 2, 3, 4 protons together. 2 beta plus decays have turned 2 of the protons into neutrons, and we've produced a helium-4. So what we've done here is brought 1, 2, 3, 4 protons together. We've had 2 beta plus decays, turning 2 of those protons into neutrons, and that has produced a helium-4 nucleus. We could consider the change of mass and or binding energy at each stage of the hydrogen or carbon cycles, but the overall effect has been to fuse 4 free protons into one helium-4 nucleus. The helium-4 nucleus has a total binding energy of 28.4 mega electron volts, and as the protons have 0 binding energy, this is the energy released for every helium-4 nucleus produced. 1 kilogram of hydrogen is 1,000 grams, or 1,000 moles, which is 6.02 times 10 to the 26 protons. 4 are needed to release the 28.4 MeVs of energy. So the energy available will be 6.02 times 10 to the 26 over 4. This is the number of helium-4 we can produce. Multiplied by 28.4, it's mega electron volts, so it's times 10 to the 6 electron volts. Multiplied by the charge on the electron to get the energy into joules, and this is 6.8 times 10 to the 14 joules.